everybody, welcome back. I hope you had a great snow weekend and vacation. And today we're going to begin 4.5, which is solving rational equations. And we're going to learn how to solve equations and identify extraneous solution. That is really a thing, okay? So first of all, a definition of a rational equation is an equation that contains a rational expression. So technical definition is an equation that contains a rational expression. The practical definition is an equation that has a variable in the denominator. Okay, so something like this. Remember, an equation has to have an equal sign. Okay, and then we have, two rational expressions equaling each other there. So first of all, what's the solution to this simple rational equation? Now, a couple ways you can do this, by the way. I'll show you one way here where I can just take this x plus 4 to remove it from the denominator. I'm going to multiply it on both sides of my equation. Okay, and that will cancel this out here. Boom, boom. Okay, and that will make this just 1 equals, and then I'll distribute this 2 through here, so it'll be 2x plus 8. And I'm going to solve for x. So subtract 8, subtract 8. So I have negative 7 equals 2x. And I'll divide by 2 to get my negative 7 halves equals x, okay? So that's one way you can do that. Another way I can do that is I have this 1 over x plus 4 equals 2. If I write this 2 over 1 like this, okay? So this is now a proportion. So remember, anytime I have one fraction equals another fraction, I now have a proportion. And our rules for solving proportion is I can take, cross multiply. So 1 times 1 is going to be equal to 1. And then I can take x plus 4 times 2 is going to be equal to, and that will be 2 times, and I have to multiply it by the entire x plus 4, so be sure to put it in parentheses, okay? And that will equal 1 equals 2x plus 8. And that should look familiar. That's right there, okay? So there's two different methods you can do that, whichever way is most comfortable, right? You can either use your proportions or just multiply by x plus 4 on both sides. Sometimes if this is a fraction over here, it's easier to use the proportion. So if there was like a 2 over x or a 2/5, it's easier to use this proportion method over here, okay? So let's go on over here. Same thing, 1 over x minus 3 equals 5. I'm going to go ahead and use a proportion method just because I want to make sure you know how to do that. So I'm going to just put that over 1. So this will be 1 times 1 equals 1. And that's going to equal, I'm going to multiply x minus 3 times 5. So it'll be 5 times x minus 3. There. Okay. So I'll end up with just 1 equals, and I'll distribute this guy here, 5x minus 15. And then I'll go ahead and add my 15 to both sides of my function. So 16 equals 5x. So I have 16/5 equals my x. And that is my solution for x. Let's do our cross multiplication because it is not a proportion, okay? This here being added together, so it's not just, one fraction equals another fraction. It is 2 fractions equal another fraction. So we cannot just do our cross multiplication. We need to use a least common multiple. So first thing, as always, we're going to factor everything out. Okay, so 1 over x minus 5 plus x over x minus 3. And then we're going to factor this guy. It's going to be 2 over. Factors of 15 add up to negative 8 are going to be x minus 5 times x minus 3. Okay. Now my least common multiple here, I need to have an x minus 3 and I need to have an x minus 5. Okay, so we're going to multiply both sides here, right, by that least common multiple. So that was going to be x minus 5 and times x plus x minus 3. We're going to multiply the other side by x minus 5 times x minus 3. Okay, so my top here is going to become 1 times x minus 5 times x minus 3 over x minus 5. Plus, in the top here is x, so we're going to leave the x there, times x minus 5 times x minus 3, excuse me, over x minus 3. equals, and I have a 2 on top here, so 2 times my LCM, x minus 5, times x minus 3, all over x minus 5 times x minus 3. Hopefully you can kind of see what's going to happen here, right? My x minus 5s will cancel out here. My x minus 3s will cancel out here. X minus 5s and x minus 3s cancel out. So my denominators should all disappear, okay? Get canceled out. If they do not, we did something weird and we need to go back and check out what happened, okay? So I'm left here with x minus 3 plus, I'm going to go ahead and distribute this guy here. So I'm going to be left with an x squared minus 5x. And that's going to equal a 2 left on the other side, okay? So we're going to have x squared, and we're going to have a x and a negative 5x, which is negative 4x, minus 3 equals 2. And we'll go ahead and subtract this 2 over here, leaving me with x squared minus 4x minus 5 equals 0. Now I can factor that guy out. Factors of negative 5 add up to negative 4, x minus 5 times x plus 1 equals 0. So my solution should be x equals 5 and negative 1. However, my problem here is, notice that right here, my solution cannot be 5. Because if I plug in 5 for x, 5 minus 5 is 0. That will be dividing by 0, and that's a problem. So this equation here has restrictions of 5 and negative and positive 3. So right here, this cannot be a solution, right? So my only solution is x equals negative 1. This 5 right here is called an extraneous solution. Extraneous solution. I think I spelled that right. Extraneous solution. Okay? So it's an extra solution you get when you end up multiplying to solve a rational expression, a rational equation. You end up sometimes introducing an extra solution that doesn't belong or is not a solution for the equation. It's called an extraneous solution. Okay? In this case, 5 is an extraneous solution. All right? So don't need this page. So right here, let's identify this extraneous solution here. Okay? Oh, sorry. I think that's an extra page. So extraneous solution, when multiplying or dividing an equation by a variable expression, it's possible to introduce an extra solution or extraneous solution. It's one that you get by solving the equation but does not satisfy the original equation. Okay, so it's really important to make sure identify what the restrictions of those equations can be and watch out for those. All right, so let's look at this guy here. We have this function here, so let's go ahead and factor 1 over x plus 2 plus 1 over x minus 2 equals 4 over x plus 2, x minus 2. Okay, so let's look and see what our LCM is. We have an x plus 2 and an x minus 2 that we have to multiply by. Okay, so I'm going to multiply both sides of my function here by those LCM. So x plus 2 on both sides and my x minus 2. Whoops, that is a minus 2, I promise. Okay, so we're going to go ahead and this will become x plus 2 times x minus 2 all over x plus 2 plus x plus 2 times x minus 2 all over x minus 2 equals 4 times x plus 2 times x minus 2 all over x plus 2 times x minus 2. So similar thing, these cancel out. X plus 2, x plus 2, x minus 2, x minus 2, x plus 2, x plus 2, and x minus 2, x minus 2. Now remember, keep in mind, my restrictions are a positive 2 and a negative 2, right? My solutions cannot be that because those are my restrictions on that function. We cannot divide by 0, so therefore those are restrictions, all right? So now I'm going to have x minus 2 up here plus x plus 2 equals my 4. This ends up being 2x. My 2's cancel out, positive 2, negative 2 equals 4. Whoops, equals 4. Divide by 2, x equals 2. Right, so that's my only solution, but again, my problem is I cannot have my solution be 2. So in this case, I have no solutions. Okay, this function has no solutions here. Okay, all right, let's go into this one. What are the solutions for this one? Now notice this 7 doesn't have a denominator. So this, remember, these are just always over 1. Don't let that freak you out, okay? My only common multiple is going to be x minus 2. So I'm just going to multiply both sides here by x minus 2 over here, and this whole side by x minus 2. Okay? So this will become 5x times x minus 2 over x minus 2 equals 7 times x minus 2. And that's just over 1. We can just leave that there. Plus 10 times x minus 2 over x minus 2. Whoops, I don't need that there. Okay, so here again, we can cross out our x minus 2's. Boom, 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 boom. All right. Now we're going to have over here our 5x equals, and we can distribute this 7x through. So 7x minus 14, and then plus, we have a lone 10 over here. Don't forget those. Make sure you watch carefully as you simplify those. So we have a 5x equals a 7x, and this is minus 4. Okay? So then we're going to take this guy here, subtract 7x. Negative 2x equals negative 4. Divide by negative 2, x equals 2. And again, we have a no solution situation because x cannot be equal to 2. Okay? So watch out for those. All right, let's try one more. You might want to pause this and try to do these on your own. It might be helpful. Okay? So this time we have a least common multiple of x minus 3, and we also have a 4, just a number. Okay? So when I multiply these guys here, I want to multiply by a 4 on both sides, and I also want to multiply by that x minus 3. You can see that. Okay, so here I'm going to have a 3 times 4 times x minus 3. Kind of a double bracket situation here. X minus 3 equals, we're going to have x times 4 times x minus 3 all over x minus 3 minus an x, watch out for that negative, times 4 times x minus 3 all over 4. Okay? Now we have our x minus 3's that cancel out, x minus 3's cancel out, and our 4's cancel out. Okay? So here we're going to have 3 times 4 is 12 equals x times 4, which is going to be 4x. And here we have a negative x. So we've got to be careful when you distribute this here. It's a negative x. So that will be a negative x squared. And a negative x times negative 3 will be a positive 3x. Okay, so watch out for those. So we're going to go ahead and 12 equals, we'll have a negative x squared and then plus a 7x here. Subtract 12 from both sides. 0 equals a negative x squared plus 7x minus 12. Now remember, I can't factor these when I have a negative x squared. So I'm going to multiply everything by negative 1 to make sure I have a positive x squared. So 0 equals positive x squared minus 7x. And then plus 12. Okay, and this will factor 2.
Call from wireless calling.
Then this will factor 2. X minus 4 times x minus 3. So my solutions here will be x equals 3 and x equals 4. Whoops. There we go. X equals 3 and 4. Okay. If it's positive 3, that's going to be an extraneous solution because of that guy, right? So we cannot have that as a solution. That's an extraneous solution. So x is only equal to 4. And there you go. Okay? All right, I want you guys to try this. Pause this video and then go through this and see how you do, and then come back and turn it on, okay? All right, so this one is kind of interesting because you can go ahead and multiply both sides by x plus 5. There's a little bit of a shortcut here to notice. I'll show you this as we go, okay? If I go x squared times x plus 5 over x plus 5 equals 25 times x plus 5 over x plus 5. This will cancel the x plus 5s on both sides, right? So I have just x squared equals 25. So notice that when my denominators are equal, that means my numerators must be also equal. So you can just skip straight down to here to x squared equals 25, okay? It's a little trick you can notice. So square root of both sides, x equals positive and negative 5 and negative 5, okay? We cannot be equal to negative 5 because of my restrictions, okay? So this right here, extraneous solution, therefore x is only equal to positive 5, okay? So that is how to solve rational functions. All right, you have an Excel 4.5 day 1, and I will see you guys hopefully soon, okay? Have a good one.